Hi, a very warm welcome to all the medium level learners. I hope few of you might have watched the beginner's level of 3 by 3 magic square using flip method. Here, you just get the 3 by 3 magic square in few seconds just by moving the numbers to its respective directions to get the magic constant vertically, horizontally and diagonally the same using the directional method. Here, one may how to calculate the sum of the magic square. It's so simple. Divide the sum of its first number and the last number by 2. Then multiply by its order. Here the order is 3. So the first number 1 and the last number is 9. 9 plus 1 is 10 divided by 2. You are getting 5. Then multiply by its order 3. 5 3s are 15. Once again, 1 plus 9, first number plus the last number. 1 plus 9 is 10 divided by 2 is 5. Multiply by its order 3. So you are getting here 15. Whereas in level 1 being beginner's level, though it's mentioned simply to add the three diagonal numbers to get the magic constant. You see 1 plus 5 plus 9 is equal to 15. 3 plus 5 plus 7 is equal to 15. In this level 2, let's see how to solve a magic square and directional method. Yes, all of us know very well about the four main directions: east, west, north and south. Apart from that, there are four more sub-directions which lies in between the main directions. That's southeast, southwest, northeast and northwest. So let's get the 8 patterns of a magic square by traveling through these main directions to its sub-directions. Yes, here it comes the very first pattern, southeast direction. Our starting point 1 lies on the east direction. Let's travel through southeast, that's which falls outside the grid. The number 2 falls outside the grid, so flip 2 to its opposite side inside the grid on the same row. Those who are not aware of the flip method, please watch the level 1 beginners flip method for the detailed explanation. Next, 3 falls outside of the grid, so gets flipped inside the grid. Oops, unable to place 4 as it's already preoccupied by 1. So 4 adjacent, that is next to 3. After this, 4, 5, 6 south direction, then 7 adjusted to 6, then 8 and 9 through southeast direction gets flipped inside the grid. That's it. All done. Check the rows and columns. Everywhere you are getting the sum as 15. Next here it comes your north east direction. Look the arrows. The numbers whichever falls outside the grid gets flipped inside the grid. So 7 goes outside to 6, which gets adjusted to its adjacent side. So 7 falls adjacent to 6. Then move northeast again. 8, which falls outside, gets flipped inside the grid. 9 falls outside, gets flipped inside the grid. So it's done. Next, here comes your arrow mark shown upwards. So northeast directional move the numbers, whichever falls out of the grid gets flipped inside the grid, and get it done. Check the total. So even northeast directional move also, you are getting the total as 15 in each row column. Here the starting point 1 lies on the west. So here onwards, on the single grid itself, explained all other numbers together. Just have a look deeply. While traveling towards southwest, 2, 3, 8, 9, whichever falls outside the grid gets flipped inside the grid, whereas 4 and 6, which are preoccupied, gets adjusted adjacent to 3 and 7 respectively. So here it's done your magic square. Get their total. It's 15 on all directions. Here it comes the next pattern of filling. Can you guess the name of the direction by looking its arrow left side upward? Yes, it's northwest directional move. Here, the first number lies on the north, so slowly move towards northwest. 2 flipped inside, column 3, 3 gets flipped inside, third row. After 3, it's preoccupied by 1, so 4 gets adjusted adjacent to 3. Sit. So observe the next numbers 8 and 9, which are also flipped inside the grid. So here it's come magic square. Here the arrow mark is shown on inclined towards the left. So you are right. It's northwest direction move. Move the rest of the numbers towards northwest direction, whichever falls outside, flip it inside the grid of the same row or same column. X, check your main sum vertically, horizontally and diagonally. You are getting the same. Yes, its starting point is at south. Arrows decline towards left. It means traveling towards southwest. Yes. So using directional move, capture actual positions and its flipped positions due to same reason. S. Here you are done with a southwest directional move of a 3 by 3 magic square whose magic constant is 15 from all directions. Here it comes last, that is the end of this directional method magic square. You see, one starts from south and slowly moves towards its direction, where 2 falls outside the grid, so gets flipped inside the grid of the same column 3. 3 gets flipped inside second row, 4 gets adjusted with adjacent number 3, 5 and 6 travels to southeast, 7 gets adjusted with 6, 8 and 9 gets flipped inside the grid. S. You are done with the magic square. Check the sum vertically, horizontally and diagonally in all the directions. You are getting the same magic constant 15. Yes. let's recap the directional moves. Two arrows of each subdirections given in 8 different patterns. Observe that its starting point differs when you observe it keenly. The first number and the middle number lies on the same row or the same column, you can say. Observe it. When you divide the sum of the first number and the last number by 2 of any odd number of magic square, it can be 3 by 3, 5 by 5, 7 by 7, 9 by 7, you will get the middle number of the magic square which falls at the center always. So the first, last and the middle number lies on the same line. 1 plus 5 plus 9. 1 is the first number, 9 is the last number, and the middle number 9. Everywhere observe it. It's lying on the same line. That is the same row or the same column. You can say the total is 15. So here you are done with all the 8 patterns of the magic square using the directional move. Thank you for watching medium level learners tutorial that's up to the age group of 12 years in directional method. Like, subscribe and share it with your friends. Watch the advanced level, expert level tutorials on Power Maths by Devi.